Dear students, welcome to the Math Olympiad Academy. Let us first explain the concept behind today's problem to help you understand it better. We are given the exponential equation, which we will label equation E1, 49 to the power of x minus 35 to the power of x equals 25 to the power of x. Our goal is the following: how to solve correctly this exponential equation E1 and determine the value of x that verifies this equation. Let us start solving equation E1 in detail. First, let us divide both sides of equation E1 by 25 raised to the power of x, which gives us the equivalent equation, denoted E2, since 49 over 25 equals 7 over 5 squared, and 35 over 25 equals 7 over 5, let us replace each term in equation E2, which becomes equivalent to the equation E3. Now, let us recall this famous rule: A power B all power C equals a power C all is power B. Apply this rule to the ratio 7 over 5 to power of 2x, which equals 7 over 5 to power of x all is power 2. By replacing this in equation E3, we obtain equation E4, which is the new equivalent form of equation E3. Let 7 over 5 to power of x be equal to t, with t positive. This change of variable allows us to rewrite equation E4 in a new, simpler form, expressed clearly as the quadratic equation in the variable t, labeled E5. In the quadratic equation in t, labeled E5, the coefficient a is 1, b is -1, and c is -1. Using the discriminant method, delta equals b squared minus 4 times a times c, which gives 5. Since this value is positive, the roots of the equation are real numbers. The quadratic equation labeled E5 has two roots, t1 and t2. The first root, t1, equals 1 plus the square root of 5 divided by 2, which is positive. The second root, t2, equals 1 minus the square root of 5 divided by 2, which is negative. Since t equals 7 over 5 to the power of x, which must be positive, only the first root is valid. The negative root is therefore rejected. Hence, the first root t1, which equals 1 plus the square root of 5 divided by 2, is equal to 7 over 5 to the power of x, as shown in equation E6. To solve equation E6 for the unknown x, we take the natural logarithm, denoted ln, on both sides. By applying the properties of natural logarithms, the logarithm of 7 over 5 to the power of x equals x times the logarithm of 7 over 5. This is also equal to the logarithm of 1 plus the square root of 5 divided by 2, as shown in equation E7. Since the natural logarithm of 7 over 5 is not 0, to find x, let us divide both sides of equation E7 by the natural logarithm of 7 over 5. This gives us the two equivalent equations, E8 and E9. To verify our solution, let us use the approximation of x, since it is an irrational solution involving the square root of 5 and various logarithms. Let's compute x with higher accuracy using equation E8, which requires a minimal number of operations. So, by replacing the values of the natural logarithm of 1 plus the square root of 5 divided by 2 and the natural logarithm of 7 over 5 in equation E8, we find that x is approximately 1.4301, extremely close to this value. Now, let us replace the value x is approximately equal to 1.4301 into both sides of the original exponential equation E1. On the left side, we obtain approximately 99.8063, and on the right side, we get approximately 99.8146. These two values are very close to each other. Hence, the close agreement confirms the accuracy of our solution. Note that the small difference is due to rounding. Using more decimal places would further increase accuracy. Conclusion: the solution of the exponential equation E1 is x equals the natural logarithm of the quantity 1 plus the square root of 5 divided by 2 divided by the natural logarithm of 7 over 5. This root is the exact solution of equation E1. The numerical approximation x is approximately equal to 1.4301, which can be used to verify the solution. Keep practicing, and we'll see you in the next problem-solving lesson at Math Olympiad Academy to acquire skills and the art of problem-solving. This concludes today's problem. To continue acquiring problem-solving skills, consider subscribing to Math Olympiad Academy.